Okay, in this video I want to talk a bit about how to set up a physics problem. This explanation will carry forward through all of your physics problems and the problems where you need to calculate an answer. And there's a few steps that I use that will hopefully help you to work through a typical physics problem. So this is coming straight from the Unit 2 assignment. If I go to the Unit 2 assignment here briefly, you'll see on the second page it gives you some formulas. The questions that you're working through here under Chapter 3 are the reviewing concepts, applying concepts, and then the problems. And it says don't solve them, just draw the diagrams for these four. When you go on to Chapter 5, you will solve the problems that are listed here. And requesting you to do those ones. But let's take a minute and set up a problem, a physics problem, the right way. In the assignment, it asks you to do these ones here, numbers 18, 19, 20, and 22. So I'm going to, I'll do a couple of examples. I'll do from the same page 61. I'm going to practice with number 17. It says a bike travels at a constant speed of 4 meters per second for 5 seconds. How far does it go? I want you to draw a diagram first, even if I'm not a great artist. You don't have to be, but you want to draw a picture of what's happening here. So I'll draw a bicycle. And here's a bicycle. And if you want, you can draw a person on a bicycle. Probably makes sense to have somebody riding it. And here they are, and they're pedaling away. They're traveling at a constant speed of 4 meters a second for 5 seconds. How far does it go? So this is a bike that's already traveling. And so if I draw some arrows, maybe it doesn't say anything about a direction, we'll just assume maybe it's going to the east. And it's going at 4 meters per second. So that's the velocity. The velocity is not changing here. So it says actually in the question, it says that the speed is constant. When you have a constant speed, that means that there is no acceleration. Acceleration equals 0 meters per second. So this is a person on their bike who's pedaling at a steady pace, 4 meters per second. So the acceleration is 0, and I don't even have to draw arrows that indicate that because it's not changing. For 5 seconds. So they start at some point, and when they get to the end here, at some point they've traveled for 5 seconds. So this doesn't say anything about that distance, right? That's what they're asking for in this question. We don't know the distance that they've traveled. It's not asking us to calculate. Actually, remember these ones. We're not solving this problem. We're just drawing a diagram, a simple picture of what's going on. Okay. So this is the first step, kind of drawing out what it is that you have. I'd like you to take it a step further and use the information that is being given here. Write down what you do know. Okay. You know that the initial velocity. So I'm going to use red here. You know that the initial velocity, I'll use I for initial, is 4 meters per second. And the final velocity is also, so F for final is 4 meters per second. Velocity isn't changing, so actually you can just list velocity like this, 4 meters per second. In some of the questions though, initial velocity and final velocity may be different, but in this one, it doesn't. We know that time equals 5 seconds. And what we don't know here is the distance. We don't know how many meters, for example, this bike is traveling. That's what the question is asking us for. If you set up a physics problem like this, it will really help you to solve this question. How will that help me solve it? Let me go back to the assignment for a minute, and I'll look at the formulas that are given. I'm going to look at these formulas, and I'm going to take a look and see, is there an equation here that includes velocity, distance, and time. And there's this one right here. This equation here says velocity, distance, and time. I know the velocity. The velocity is 4 meters per second. I know the time is 5 seconds. The only one I don't know is the distance. So if I put my values in, I can calculate it. Displacement is a fancy physics way of basically saying the distance. And so that's good to keep in mind as well. And this is what I do with when I'm solving a physics problem. I want to figure out which formula should I be using, and it's the one where you will know all of the variables, all of the letters. You'll know all of them except one. Then you can solve using that formula. Okay. I'm going to go on to do another question here. I'll take a look maybe at another example. I'll actually probably stop the video here and try number 21. It'll be the next video in this series. Go to 21 and see if you end up with a similar answer to what I do. And we'll pick it up again in part 2.